What is up, Foundation crew? All right, I promised I would post up a video on how to do a problem like this, right? Turning the secant line into a tangent line, right? Using this formula from class. So if you missed class, I'll do a quick recap. Basically, we talked about slope. We talked about like finding like the slope between 2 points, right? If you guys can look at this picture and look at the red line, or I'll highlight it a little bit more, right? And what we talked about was turning this red line into the blue line, okay? The red line is called the secant line, right? Slope of the secant line, right? And then the blue line is called the tangent line, okay? So the red is the secant line, and the blue is the tangent line. And just as a quick reminder, right, secant line goes through 2 points, tangent line goes through 1 point, right? And we were saying how like tangent lines are important because like we want to know, or I guess people that are studying rates of change and stuff want to know how fast something is like changing at a moment, at a given notice, like at an exact point. So in this example, what we're doing is we're looking at 2 specifically for this function. I think I gave this function as an example. And we're coming off of 2 just a little bit. And that little bit is called h. Okay, I just gave it, it could be a 5, it could be point 0, point whatever, but we want to turn it into h, a variable, because essentially what we want is we want that h to get closer and closer to 0. And that's where this limit came into play, if you guys remember from class, right? We want that limit of h going to 0 so that the q point, this second point, will then like get closer and closer and like fall on top of the p point, this guy right here. All right, so that's a quick recap. If you need more detail, please just set up a time to meet with me. And then what we did was we found the slope of the secant line, right, using these 2 points, right? These are the 2 points P and Q, right? We just used y2, y1, x2, x1, and we found this equation right here. And now this is a really important equation, a powerful equation, because this is actually the slope of the tangent line. And more specifically, we're going to learn probably next class that this is actually the derivative. This is called the derivative at a specific point. In this case, this is the derivative at x equals 2. Pretty cool, right? I know. So how do we use this thing? Well, if my function is 1/3 x squared, well, I am going to plug in these values into my function. That's what this notation means, right? F of 2 plus h means I take 2 plus h, put it in for x, and see what I get. So why don't we do that? Let's take 2 plus h, put it in for x. Let's take 2, put it in for x, and like rewrite this thing. All right, so what are we going to be left with here? We're going to be left with limit as h goes to 0 of f of 2 plus h. So it goes, I'm going to write down the function, which is 1/3 times 2 plus h, and then squared, right? Minus f of 2. So that means I'm plugging in 2 into my in for x. You guys see what I did there? All I did was I replaced the x with my inputs. In this case, they were 2 plus h and 2. All right? And then from here, we just simplify. We just do some algebra, right? So this becomes limit as h goes to 0. We'll get to that in a second. On the top, all we're going to do is multiply everything out. So we get 1/3. Let's see, 2 plus h squared. Be careful, it is not 4 plus h squared, okay? 2 plus h squared. 2 plus h squared is 2 plus h times 2 plus h, right? So you guys probably guess what we're going to have to do here. We're going to have to distribute this all out. So if I distribute this all out, I get 4 plus 4h plus h squared. So let me write that here. 4 plus 4h plus h squared. Then we go minus, what is this here? This is going to be 4 over 3 all over h. We're not going to use this limit thing yet. We still can simplify the top. So why don't we simplify the top a little bit more? And maybe you guys, you might see it right now. I don't know. But let's see here. I'm going to distribute the 1/3 in. I get, ooh, look at that, a positive 4 over 3, plus 4 over 3h plus h squared over 3, and then I can't forget about the minus 4 over 3. This is all over h. This then becomes, 4 over 3's cancel out, which is nice. What you should see here is that these two terms actually have an h in common. Do you guys see that? Right? This one has an h. This one also has an h, right? Or at least an h squared. So in this step, what I'm going to do is factor out an h. I'm going to factor out the h. I'm left with 4/3 plus h over 3 all over h. And this is good. This is really good. Why is this good? Well, before, if I let h go to 0, if you guys look in the beginning, right? If I were to let h go to 0, you guys notice that I would get something like undefined. I would get something actually, it's indeterminate. And like it was kind of like a useless answer. And this should start ringing some bells. Remember when we were doing limits and we were talking about like when we would get like 0 over 0, which doesn't make sense. So in this case, because the h's cancel out, we're going to be left with this, limit as h goes to 0 of 4/3 plus h over 3. And look, now I can take the limit as h goes to 0. I can like just substitute 0 in for h, right? That's what we used to do with limits. And watch what happens. I'm left with 4/3 plus 0 over 3, or just 4/3. Oh my gosh. What does that mean? What does this number signify here? Well, if we kind of go back, 4/3, this is the slope of our tangent line. That means the slope, the rate at which this graph is changing at 2 is 4 over 3. I'm going to write that down here as emphasis, right? This is the slope of the tangent line. Nice, we did it. All right, so meaning the rate of change at x equals 2 is 4 over 3. That is like the full-on answer for this thing. Okay, but I know one example is not enough for you guys, so I will do one more example. So let me just pull up one of the problems. Number 9. Oops. In black. Number 9, it says, so if you guys saw the new directions, I said to skip parts B and C. We didn't talk about tangent and normal line yet. We'll talk about that next class, all right? So basically, for number 9, what number 9 is asking you to do is, for this function, y equals x squared, they give you an x value, kind of like what we were given, where is it? Oh my gosh, what we were given up here, an x value. In this case, our x value was 2, but for this problem, our x value is -2, all right? Meaning, what is the slope at -2? So they're asking, what is the slope of the tangent line at x equals -2? So we're going to need to use that formula again, all right? I'll write down the formula, the general one. It goes limit as h goes to 0, f of a plus h, and this is the point that the x value that you're interested in. The x value. In this case, it's going to be -2. And then minus f of a. This is also that x value. All over h. All right. So all we need to do for this one, we're going to plug in. We're going to plug in our a value. So in this case, our a value is -2 plus h minus f of -2 all over h. And then we're going to use our function now, right? We have a function which is x squared, and see what happens. So let's see. I'm going to plug in, I'll rewrite my function down here. It's x squared. I'm going to plug in -2 plus h. I'm going to plug in -2 plus h into x and see what I get. That's going to give me my first term. So I plug -2 plus h in for x. What am I going to get? I get -2 plus h. That's a 2. Quantity squared, because that's what my function is telling me to do, right? To square the input. Minus, all right, I'm going to plug now -2 into my function. What do I get? Well, that's just negative 2 quantity squared all over h, and can't forget the limit. All right, so we just simplify this thing. Something should simplify down. There should be a part where like the h's cancel out, and you should be able to get a numerical answer for this. So I go limit as h goes to 0. So I distribute this first piece out. Excuse me. I distribute the first piece out, so negative 2 plus h squared is negative 2 plus h times negative 2 plus h. And I'm going to distribute or FOIL everything out, right? Distribute everything out. What is that? 4 minus 4h plus h squared. This becomes 4 minus 4h plus h squared. So that was this first piece. We can't forget about the second piece, which is minus 4, right? Negative 2 squared is 4, all over h. And oh my gosh, you see it again, right? There's going to be a step where like the numbers kind of cancel out, and you're left with negative 4h plus h squared. Well, they both have an h in common, so I'm going to factor out an h, leaving me with negative 4 plus h all over h. And oh my gosh, just like the one before, right? The h's cancel out. And now I can apply this limit. What happens when I let h go to 0? When this h goes to 0, I'm left with negative 4. All right, so that is the answer to number 9. That is the slope of x squared at x equals negative 2. And just to give you like a pictorial reference here, right? So this is x squared. This is my function. And negative 2 is like somewhere here, right? And the height is 4. And what this is saying is the slope of the tangent line, meaning if I were to draw a line right on top, like I could zoom in like an infinite amount of time. If I were to draw that tangent line right on top of negative 2 comma 4 at negative 2 comma 4, if I were to draw that tangent line, well, the slope of that tangent line, the slope would be negative 4. It's like saying that it's changing at a rate of negative 4 over 1. Like it's going down over 1 at that point in time. Okay? So hopefully this will help you with number 10, and I think this should help you with number 7b also. It says to estimate the speed, but it's like saying like, it's asking what is the rate of change at p, you know? So if you're looking at the other like secants, right, with Q1, Q2, Q3, Q4 for number 7, like it should be approaching like a value, and that's what you're going to use to answer 7b. All right, so this should be a big help for number 10, so I should see some really good looking homeworks this time around. Okay, I'll see you guys. Let me know if you need anything. Bye.